Find the perimeter of triangle ABC. So what we have to do is we have to use the distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y sub 1 squared. Or you could do Pythagorean theorem, but in this video we're going to use the distance formula. In order for this to work successfully, we need to keep ourselves organized. We have 3 line segments, so that means we're going to be using the distance formula 3 times. Our first line segment is AB. Our second line is BC. And our last line here is AC. To use the distance formula here, we need to know the coordinates. So A is going to be located at -8. 5, I believe, 1, 2, 3, 4, 5. B is going to be located at -4, -6. We're going to reuse these on the ones that we have to. This one, A, is at -8, 5. And we can say B is at -4, -6. Now we just need to find point C. 5, 1. And then C is at 5, 1. Alright, to make sure we're successful with this, we do need to label our subscripts. Let's work on our green line segment first. x1, sub 1, x2, y2. We're going to use the distance formula here, which is right there, a little hard to see. So we have D is equal to the square root of -4 plus 8 squared plus, the reason why it's negative, -4 minus -8 makes it a positive. Then we have -6 minus 5 squared. This would be equal to the square root of 4 squared plus -6, -11 squared. You get this is equal to the square root of 16 plus 121. 16 plus 121 gets you equal to the square root of 137. We'll just keep it like that for now, and just keep yourself organized. Put that 137. We're going to do the same thing here. x1, y1, x2, y sub 2. Okay? Since I don't have much space here, I'm just going to draw it right here. So we have D is equal to the square root of 5 plus 4 squared plus 1 plus 6 squared. Right here you get this is equal to the square root of 9 squared plus 7 squared, which you get 81 plus 49 square root. 81 plus 49 is equal to square root 130. We could simplify that, but let's just keep it as square root 130 right now, just like what we did for the 137. So right here, 137, or 130, sorry. And then finally we have right here, actually didn't need all that space, so x1, y1, x2, y2. D is equal to the square root of 5 plus 8 squared plus 1 minus 5 squared, which is equal to the square root of 5 plus 8 would give us 13 squared. And then we have 1 minus 5, that would give us negative 4 squared, which is equal to square root of 13 squared, 169, plus 16. And then from here, you have 169 plus 16 should be 185. So to find the distance, you can add them all up. Let's simplify these radicals and get an exact answer. See if we can get an exact answer, and then let's get an estimate. So 130 can be broken down to 2, and 65, that can be broken down to 5, and 13. Nope, that can't be broken down at all. I think that's how we look. 130 divided by 2, divided by 5, yeah. So that's as prime as it gets. Let's try 185. 185 divided by 5 gets us 5 and 37, doesn't break down. So our exact answer would be the following: 137, square root 137 plus square root 185 plus square root 130. That would be our exact distance. If you want to get an estimate, you're in luck. All you have to do is just plug in the numbers and don't round to the very end. So you would do 137 square root plus 185 square root plus 130 square root. And you would get the distance is equal to 35.68 units. Again, you would just type in 137, then square root. Add 185 square root equals plus 130 square root equals. And you get that answer. There you have it.